Modified Kalman filtering method for discrete signal. Introduction. Currently, it is an urgent task to create digital filtering methods used for noise suppression, which are used in computerized biometric identification system. One of the popular digital filtering methods is smoothing adaptive linear filtering. For smoothing adaptive linear filtering, the identification of filter parameters plays an important role. Approximate methods of determining parameter values based on global search do not guarantee convergence. Absolute methods of determining parameter values based on a local search have a high probability of hitting a local extremum. Exact methods of determining parameter values have high computational complexity. Thus, the problem in insufficient quality of parametric identification methods arises. Modern heuristics and meta-heuristics are used to increase the speed of filter parameter identification and reduces the probability of hitting a local extremum. Meta-heuristic expands the capabilities of heuristic by combining with a method based on higher-level strategy. Meta-heuristic often use the behavior to evolutionary and among approaches, meta-heuristic and approximate and, as a rule, stochastic methods. This effective meta-heuristic use experience to accumulate during usage and storage memory. Purpose and objective of the research. Objective of the research. The process Kalman filtering of discrete signal. The object of the research Kalman filtering methods for a discrete signal using parametric identification based on immune meta-heuristics methods. Purpose of the research is to improve the quality of Kalman filtering of a discrete signal using immune meta-heuristics methods. Objectives of the research: create a modified Kalman filtering methods, develop a DNS optimization method based on artificial immune network, create a continuous optimization method based on hybrid immune algorithm, conduct a numerical study of the proposed methods of continuous optimization and Kalman filtering. Modified Kalman filtering methods. In this work, it is assumed for a moment of times the matrix, the control matrix, the control vector, the process covariance matrix, the observation methods are replaced by vector. The observation noise covariance matrix is replaced by the scalar. The observation vector is replaced by the scalar. The observation vector estimate is replaced by the scalar. The error vector is replaced by the scalar. The error vector covariance matrix is replaced by the scalar, and the optimal Kalman gain matrix is replaced by the vector. This reduces the amount of computation and the amount of specified data. The modified Kalman filtering method of discrete signal is following stages. Initializing, focus stage, calculate the data vector estimate in this work, calculate the covariance matrix of the state vector estimate in this work, where update stage, calculate the estimate of the observation vector in this work, when calculate the error vector in this work, calculate the error vector covariance matrix in this work, where calculate the optimal Kalman gain matrix in this work, where updating the state vector estimate in this work, updating the covariance matrix of the state vector estimate in this work, where selection of criteria for evaluating the effectiveness of the modified Kalman filtering method. In this work, to evaluate the effectiveness of the modified Kalman filtering method, the accuracy criterion is chosen, which means choosing such values of parameters that provide a minimum root mean square error. The accordance with the selected criterion, immune meta-heuristic method, and defined parameters are proposed in this work. Modified artificial immune network method. Initializing, iteration number, calculating the efficiency of population cells, order the population by the target function, determine the base cell by the target function, depending on the global best cell. If condition is satisfied, then calculating the average cost value, creating by the best mutated clone set on based cache distribution. Calculating the average cost value. If condition is satisfied, then go to step 8. Compressing the set and replacing population cells with element of the set. If condition is satisfied, then go to step initialization of the last population cells. If condition is satisfied, then increment and go to step 3. Modified hybrid immune algorithm methods. Initializing. Iteration number. Creating the best mutated clones set based on cache distribution. Modification of population. Adding cells from populations that have reached age to the set of memory cells. If condition is satisfied, then go to step 8. Set compression. Determining the best memory cells of the set by the target function. If condition is satisfied, then increment n, go to step 3. Experiments and results. The numerical study of the proposed meta-heuristic methods was carried out using the Python package in the Google Colab environment. Numerical experiments were carried out using the parallel information processing technology of the GeForce video card by 1025 threads in the one-dimensional world. In this work, the following parameters were used: was a modified artificial immune network methods, the maximum number of iterations, population size, number of clones, parameter for generating a new solution, and compression threshold. In the work, the following parameters were used: was a modified hybrid immune algorithm methods, maximum number of iterations, population size, number of clones, memory size, compression threshold, maximum cell age, and memory oversize factor. In the work, one dimension signal generated of which also noise with zero mathematical expression and dispersion on edit. In the work, the following root mean square errors were calculated based on the formulas. Table 1 presents the root mean square errors for immune meta-heuristic methods for all the methods. Clonal selection method, modified artificial immune network methods, modified hybrid immune algorithm methods. Original signal without noise and signal with noise. The original signal without noise and the observation estimate. Conclusions. A modified Kalman filtering method was developed that provides automation of parameter values dimension and increases the speed and accuracy of Kalman filtering by using fewer parameters and identifying them based on immune meta-heuristics methods. A modified artificial immune network method was created that reduces the probability of convergence to a local extremum by using the cache distributions and makes the proposed methods more accurate than the existing one. A modified hybrid immune algorithm method was developed, which by using the cache distribution reduces the probability of convergence to a local extremum and makes the proposed methods more accurate than the existing one. Algorithms of immune meta-heuristic methods were identifier Kalman filter parameter have been developed, which are intended for software implementation on CPU using CUDA technology, which increases the accuracy of Kalman filter. The numerical studies conducted have confirmed the operability of the developed software and allow us to recommend it for practical use. Further research space includes the use of the proposed mathematical heuristic for various generated purposes and the result purpose intellectual system, for example, for the training neural network. Thank you for attention.